Hello, this is Mr. Huff. Let's look at some aircraft flight data. This is glider data over the last couple of years from 2020 to now. And you can see that our AERO numbers, 155, a max of 240, and a standard deviation of 20. And if it's a normal distribution, then that means that our AERO numbers are 155 plus or minus about 60 to cover most of our data points. So we can say safely that we have a mean of 155 on the AERO number as far as design goes. We'll look at AERO numbers more in just a moment. On the distance average, so this is the average of all of the test flights, 39.6 is the average, and 83.8 is the max of those averages. So that was the highest one. We have a standard deviation of 14.5, not really useful here at this point. And then our distance max, we have a mean of the distances. So this is out of all the maximum distances, if we average all those together, the typical maximum flight is 63 feet. We have a max of 100, which is the upper limit of what we can test in the space. So if we had more room, like a longer space to fly these in, we could get more accurate numbers there. Or if we flew them outside, maybe that would change things. My experience has been when you throw weather in on top of this, it makes it a lot more interesting. So here again, we have a standard deviation of 20, which means that from 63.3, if you go plus or minus 3 standard deviations, that goes from 0 to 120 as far as our distribution, if it's a normal distribution. All right, only this year, so this is the data I have so far, and it looks like a lot of you have already submitted this, so the mean AERO number is 146, so it's a little bit lower than the average I've seen over the last couple of years. And our max is 171, so you guys, no one pushed it like that 240. The average distance is really close at 35.8 versus 39 for all of the data. And then the maximum of the distance average is a lot less than the 83. So what that tells us is we had a lot more planes go a lot further like last year. So if we look at the maximum distance, we're seeing that the average of the maximum distance is very similar at 62, and we also have a max of 100, and the standard deviation is a little higher. This means that our spread of data is a little bit bigger, but it's actually pretty much the same. So this is a really telling number right here, because it's very consistent between the two models. So what I would challenge you to do is, this is useful information for you to use to evaluate the performance of your own plane. You can talk about everything that's happened since 2020 and stuff that's happened just this year and compare that to your performance. All right, ladies and gentlemen, let's take a look at this. This is the distance values versus the AERO number. So on this side, we have the distance, and down at the bottom, we have the AERO number going from, this is a terrible graph. It goes from 125 to 225. It's kind of weird here because you normally would start at 0. So here we have the scatter plot, and when you look at this, it's clear that things are not very clear. So the blue dots are average distance, and the red dots are maximum distances. So for instance, on this data set at the right, you can see this was the average, and this was the max. All right. Normally, when you have a correlation between something like distance and AERO number, you would expect the data to kind of follow a pattern, like a line that you could do a regression analysis with, and you could just kind of do a regression analysis and get a curve fit there, but we don't see that here, do we? What we see here is a group of unrelated points. So we've got, as the distance increases, the AERO number may or may not increase. As you can see here along this top edge, right here, we have a very low AERO number. This would have been around 130-ish, all the way to this AERO number, almost 100 feet, and it's over 225. And then we have one right here. We have either side of our average. Our average area number would have been right about here, and we have one that's below that and one that's above that. And similar with the averages, you see this cluster right here. So when you see these clusters, that's not really showing you a relationship. What you're looking for is some dots that kind of line up along a line. So there is no direct correlation with the area number from what we can tell from this graph. But if you want to draw some conclusions based on this, you can certainly do that. All right, that's all I have for now. Thank you for watching.